Alright, so today we're going to look at 9.3, graphing ax squared plus bx plus c. So we're going to review how to graph the quadratic equation. And the one thing we want to look at here is we're going to graph y equals x squared for the integers -3 through 3. So I'm going to make a table. And I'm going to go -3 through 3. So you can do the same thing in your notes. At any time during the video you can pause and you can write it down and then start back up again. So here, looking at the equation, we're going to put -3 in and square it for this equation, so we get 9. Alright, I'm going to pause the video and I'm going to graph this and then we can answer our questions. So hopefully you took the opportunity to also graph the values onto the table. And here we want to look at the questions now. So it says, describe its shape. So here we know we have a shape and it's U-shaped. And it is opening up. So then we asked ourselves, what type of symmetry does it have? And we learned back in 9.1 and 9.2 that this has reflection symmetry. And the third question says, where is its vertex? So here, I'm going to put that in blue, and its vertex is 0, 0. The next question says, what is the equation for the axis of symmetry? Well, if you notice the axis of symmetry here, I'm going to put it in red, is right along the y-axis. So x would be equal to 0. So the next question asks us, find the x-intercept if they exist. So looking at that, the x-intercept is where does it cross the x-axis? And that's right here. So it touches there right at 0. It's also the same for where it crosses the y-intercept. Here is also at the same. So you would write, find the y-intercept, it would be y also equals 0. So 7, 8, 9, and 10, this is review from class the other day. So when a is greater than 0, a is positive, the graph will open, and we know that it opens up. When a is less than 0 and a is negative, the graph will then open down. The larger a is, the graph of the y equals ax squared appears, the steeper it is. So it will look like that. And it's steeper. So the smaller a is, like say, 0.25, I think was the example we used last time, means that it will have a much more gradual increase. Alright, so let's take a look at the next page. It says use symmetry to complete a table of values for y equals ax squared plus bx plus c and locate a vertex. So here if I look at -5, the value would be -35. So over here, if the value is 5, I'm just going to extend my table out a little bit longer. You can do the same. The x value at the -5 at positive 5, it's going to be the same at negative 35. So here at negative 17, this would be a positive 4. At 3, this would be a negative 3. So you're just kind of going back and forth. And here, negative 1, it's 13, so at 1, it's also 13. And then we have a value of 0 here for 15. So if you kind of look at that, you'll see that these are the same and these are the opposite. And that's true. Oh, I didn't do this one. So this would be negative 17 as well. This would be the same as that, and these would be the opposites. All right, so part C says graphs of quadratic equations of the form y equals ax squared plus bx plus c. Give the values of a, b, and c for the equation y equals negative x squared minus 4x minus 3. So here, value of a would be negative 1, the value of b would be negative 4, and the value of c would be negative 3. Don't forget those signs that are to the left of each of the numbers. That's going to make a difference. Looking at this, we can tell that the number attached to the x squared is negative, so the graph is going to go down. All right, so let's work on this here. We're going to graph this equation for the values of negative 3, 2, 3. So same thing as the first one, negative 3 all the way down to 3. Move that down a little bit farther. Now we're going to evaluate each of those into this equation and find the value of y. I would advise grabbing a piece of scratch paper to evaluate these, so I've done that already. And I'm going to plug in the first value of negative 3 from my table into this equation and solve for y. So when I do that, I get negative 3 squared is 9, and I'm going to bring down that negative sign. Negative 4 times negative 3 is plus 12, and then I have the minus 3. So here it says y equals negative 9 plus 12 is 3 and minus 3, so y will equal 0. So I'll head back to my table and put a 0 in here, and I'm going to do that for each of the following values of x. So you can pause and work on those on your own, and I'll come back and finish up the graph. As you can see, I worked out the values for all the y, and then I plotted the points on the graph. I can mirror this on this side, reflect it, and end up with something quite similar to the other side. So here it says describe its shape, and we have the U shape, and it's going down. What type of symmetry does it have? If I were to find those values, I would find that it was reflective, or reflection symmetry. Its vertex here, I'm going to put in green, has a value. If you noticed, I used a scale here, so over 2, negative 2, and 1 here. It says, what is the equation for the axis of symmetry? So the symmetry is where it crosses that x-axis, so x would equal negative 2. And what is the x-intercept? It is also negative 2. Part E says find the x-intercept if they exist. So the x-intercept is actually at this place, and I'll put this in gray, where it crosses here. So there's two values here. I have x equals negative 1 And x also equals, if I go up here, 1, 2, 3. So x equals -3. And in black, I'll put the y-intercept, and that's where it crosses the y. And it looks like here it crosses right about 2, 3, I guess I didn't draw my line very well here, so it really crosses right here at -3. So we'll put that here, y equals -3. So we're moving on now to part D, and it says analyze the graph of the quadratic equation below and identify. So here's our graph here, and I'm going to grab a marker, and it says what are the x-intercepts, and the x-intercepts are right here where the line crosses the x-axis. So here I have 1, 2, 3, 4, 5, 6, 7, 8. So I have -8, 0 is one x-intercept, and 1, 2, 3, 4. So 4 and 0. So there's 2 of them, remember? And then the y-intercept here is where does it cross the y-axis, and that's down here, and that's where 0, -7. I'll put my vertex in green, which happens to be down here. So let's count that spot. We have go over -2 and down 1, 2, 3, 4, 5, 6, 7, 8. So -2, -8 is where my vertex is. And if I want to know where the line of symmetry is, it's right here. And it crosses the y-axis at -2. So, or I'm sorry, the x-axis here at -2. So you'd say x equals -2. So this is your line of symmetry. This is your vertex down here. Okay, then you have your x-intercepts, and then I'll put the y-intercept in black here, so you have all those. You'll need to be able to identify that on your test next week. Alright, so graph investigation 1, it says sketch each of the graphs of each equation on each axis below. What is the effect of adding a constant? That's our c values. Notice there is nothing here, or it would be +1, +3, or -5. What happens to the graph? So when I just have y equals x squared, it's going to start right there at the origin and go up. Okay? When I have a +3, I'm going to move that graph up 3 because that's where it crosses the y-intercept. I'd put my dot there, and then that's where my parabola would start. And then -5, I bet you guessed it, it's going to go down 5, and it's going to start right there. Lastly, in this section, we're going to start with what happens when we add a constant of b. So notice it's within the parentheses. What's going to happen to the graph? So first one is exactly like we did before. There's nothing added to it. Second one, we have a +2. That means since it's a +2, it's going to move to the left. So I'm going to move it over 2 spaces, to the left and up. So this one I'm going to move now, since it's a negative, I'm going to move it to the right 6 places. And you guessed it, this one's going to go left again 3 places. And that's what happens when you add a b to your equation. And so now you're ready to get started on your homework. I hope this video helped, and if you have questions,